Getting out of the prison called life. Yes, I know that we can make it. Let me go on the way. Jumping hard and climbing all heights is a risk, but we can take it. Let me go on the way. We're abundant, yet we're underappreciated. That's not fair, or is it? Down under the shining beauty of everything, we're there to serve them. I am a neutrino, oh, no dropping amino, oh, no trading like zero, oh, just existing in paddle. Thinking about the very thought of living and the panic and grieving of the pain I got. Whenever you need it, I'll be ready for you, baby. I can only do so much.
Come on, AT, rocking up beat over 2 feet. Wood on the street, yeah, we heat it like a treat. Retreat, never recede. Always be free, big heap, but the rich gold in the whole week. Yeah, there's a whole lot in the jar. No, I ain't talking, I'm a superstar. Take my warning, she would take you far. If you don't know her, she's bizarre.
Abundant, yet we're underappreciated. We both know that we're gonna change it. Down under the shining beauty of everything, we're there to serve them. I am a neutrino, oh, no topping amino, oh, I wanna be a hero, oh, just existing in paddle. Getting out of the prison called life. Yes, I know that we can make it. Let me go on the way. Jumping hard and climbing all heights is a risk, but we can take it. Let me go on the way. We're abundant, yet we're underappreciated. That's not fair, or is it? Down under the shining beauty.
Hello everyone, welcome to the Introduction to Cybersecurity workshop, or rather the long-awaited comprehensive Introduction to Cybersecurity workshop. I am trying to, okay. So the workshop was initially planned a long time ago, somewhere around, you can say 2-3 months ago, and we had a version of this workshop back then which was quite disastrous, if not very bad. We plan to do an improved version of this long back, so we had been doing preparations for this workshop all along, and we've come a long way. Lots of preparations done, lots of things created, and finally we are here with the workshop. Let's go ahead. I'll tell you a little about myself. Most of you already know me. I am Param Siddharth, currently in my second year of BTech. Not really, I'm about to go into my third year. I am primarily a software developer and a musician, and I have little to do with cybersecurity, but still I am here conducting the workshop, so let's see how it goes. I, along with Ritesh, am the club administrator of PyData, and if you don't know about our club, it is a club we opened last year itself in our college in Guna. And if you would like to be a part of the community, you can join our Discord server. To that will be the description of this video. We conduct workshops very often and hold meetings, and we're planning to grow our community with the coming days. So do check it out. These are my links. If you want to contact me on the social media for any of your doubts, you can. As any typical workshop does, we'll begin with the question of what exactly is cybersecurity? Now, cybersecurity has many names. Some people call Can you hear me now? Maybe you must be seeing a dark screen again. Okay, very well. Let's continue with the workshop. I have connected to my Wi-Fi. I am risking it. If the electricity goes off, everything is gone. But I'm trying to rely on it. Okay. Can you? Okay, very well. So cybersecurity has many names. It is also called information security. Some people call it computer security, and you'll find a large number of definitions of cybersecurity online. But I would like to give you the definition that I wrote myself, which I consider the perfect definition of cybersecurity: the study, avoidance, and cure of vulnerabilities and loopholes in computer software and hardware systems that permit unintended access, manipulation, disruption, or damage of anything. So, cybersecurity pertains to any kind of loophole, either in software or hardware systems, that can cause unintended access or damage to anything, to data, to the system itself. Why should you care as someone attending this workshop about cybersecurity? Depends on who you are, a developer, a regular person. So as a regular person, you should care about your personal safety. So this workshop is going to educate you about how to be more careful online. You know how we are careful in our personal lives, going outside. At this point, we need to be just as careful online as we are in the real world. The second important idea behind this is general awareness, because I see lots of rumors going around, WhatsApp forwards that say, open this link, share this with 5 friends of yours, and maybe you'll get a free award by Flipkart. That it doesn't work that way, and people are not aware of how to find out whether it is true or not, and they just keep on spreading the rumor. So the understanding of cybersecurity is supposed to change this about you as well. The third idea is decision making. When you are launching a product in the market, oftentimes you always care about the quality and availability of the product, and you forget to think about the security aspect. And this is often a problem with startups, especially. So for them as well, they need to be careful about a number of things, which we are going to discuss in the workshop. Application safety, as I mentioned, and finally quality. When you launch a product in the market, a software or hardware product, and it needs to cater to a large audience, and you want to maintain its availability without causing any significant loss to the infrastructure, there also you need to be careful about some bad people out there who can damage your application by intruding themselves into it. So that is yet another reason to be careful, to be concerned about cybersecurity. Now, what should your expectations from this workshop be? This is one of the most important phases of the workshop. So I'll start with this. A certificate, of course, because you have taken out your precious time to attend this workshop. You'll be awarded a certificate of participation, and I will be keeping my eye on the live chat and answer all the questions as they come, so that none go unanswered. I'll try my best. And you can expect a safer life online and offline after learning about the different kinds of vulnerabilities in the software world. And your perspective of the cyber world might change after this workshop. Now, there are some very important points to note so that you don't have your expectations too high. This workshop is just the beginning. This is the start of something new, the start of your learning of cybersecurity. If you are a beginner, if you are someone in the intermediate level and already know a lot, maybe you will still get to learn about something new. I am not much of a cybersecurity person, but I'm trying to deliver it as well as possible. Cybersecurity is not networking. Cybersecurity does comprise a lot of networking, but it is not only networking. There's a lot to cybersecurity that does not pertain to networking. There's so much about it to explore online. So after this workshop, you can take forward your wants and needs and learn about new things altogether. Breadth and not depth. The purpose of this workshop is to go as wide as possible and not as deep as possible. Now, some of you know about the concept of DFS and BFS, those algorithm students, depth first search and not breadth first search. So we are aiming at breadth, not depth. We are planning to cover as many concepts as possible and not diving too deep into any particular concept. Which is something about this workshop you need to be careful of. Non-standard terminology warning. Well, a lot of the terminology that I'm going to be using in this workshop, you are not going to find that in the first Google search, maybe. So a lot of the terminology that I'll be using could be standard, could not be. Be careful about that. Not everything you're going to find on Google. Can you hack your friend's Instagram account after this workshop? Well, I really think you can't, and you shouldn't try to see cybersecurity from that perspective, because if you are, then maybe you're at the wrong place. You're better off somewhere else. This is not supposed to be an unethical workshop where you learn about hacking accounts. We are just going to cover a large number of concepts in cybersecurity. When will we start? We have already done a large number of formalities here. So when are we going to start? We begin right away. That's the end of all formalities. We can get started with the workshop. And although I'll be showing a lot of slides in the presentation and explaining lots and lots of concepts, be patient, because there is a hands-on after every single concept, and I'll show you in action what I intended to tell in the concept. The repository. So every single hands-on exercise that we are going to perform in this workshop is going to be available in this particular repository. A link to that you will find in the description of this video as well, so that later on, and I've added all instructions in the form of readme files. So if you want to perform the same hands-on on your own in your own machine, you can follow that. And for most of them you will need Docker, because I chose to use Docker for virtualization for most of the demonstrations. So you will need that, and then you can try them on your own. For now, just see how I do it. Okay, time for the attendance. So have a look at the live chat. I just posted a link for the attendance. Let me pin that message and go ahead and fill it, all the people on their mobile phones. This is required for the certificate of participation, because that's how I know that you actually participated in the workshop. I can already see 35 people, although 114 had registered, and it is expected. Usually less than half the number of people who register actually attend the workshops, so that's fine. Okay. Here we begin with our first concept of the day, which is validation. Validation, as the name suggests, means checking if something is correct. Now, what exactly are we checking? Anything that comes into the system, that's what we are going to validate. So this can also be called input validation. Now, how can this be attacked? How exactly can someone exploit this? By doing false validation, by making the system believe that something is valid when in reality it is not. And there are multiple ways to do this. We'll have a look at maybe 4 ways of doing that. So we are making the system believe everything is going as intended, whereas in reality it is going as we want it to go. So it is going how we intend it to and not how it should. Now, how do we avoid input validation attacks? To avoid such attacks, we need to have proper sanitization and verification in the application's backend. Sanitization has become a very popular term during the lockdown, so you might already be knowing about this. And the same applies to the backend, and it has been for a very long time. We'll see how. The first example and the first sub-concept of the day is SQL injections. Now this some of you could have already heard about this. This is a very popular attack, and surprisingly a large number of applications currently on the internet are still vulnerable to something as simple as an SQL injection. An SQL injection is injecting unwanted code into the internal SQL queries of the application. And I assume most of you know about SQL, but those who don't, SQL is a query language. It is used to ask queries. It is used to make queries to the database engine, to ask questions about the database, to retrieve data, to update data, to remove or add data. Now, SQL injection attacks exploit the inner working of the application. So they make the application behave differently from the way it should. And this is mostly due to the lack of sanitization that applications become vulnerable to this kind of attack. And I'll explain how it works. So here's a very simple query. Even those who don't understand SQL can get from this. Select star from users where password is equal to something the user inputs. So it is going to find the user whose password is this. So it is maybe doing something similar to a credential check. So I enter ABCD1234. That looks like a password to me. So the query becomes select star from users where password is equal to ABCD1234. This becomes the entire query. Now this query is supposed to run and check if the password is correct, then nothing would be returned. Then something would be returned, and if the password is wrong, nothing would be returned, and hence the system will know that the password is wrong. So this is the condition, password equal to ABCD1234. This condition itself determines whether the system perceives the credential to be correct or not. Now how can we exploit this? Let's see. Now anything I input will be added here, anything. So what if I enter this? Now this doesn't look like a password, and it also has quotes in it, so it looks even weirder like this. What happens if I enter this? What happens if this becomes a part of the query that is going to be executed? So let's just take this tiny section and put that here. This is what the query becomes. Select star from users where password is equal to X or param is equal to param. Now password is equal to X. I am pretty sure there is no one whose password is going to be X. But param is equal to param does make a lot of sense, because param is always going to be equal to param. This sequence of characters PARAM is always going to be equal to the same sequence of characters. And there's an OR. So this entire condition is always true. And no matter who the person is that I am trying to authenticate as, if I enter this query will always be valid. This X will not matter. I can even get rid of this X. But this query will always be true. And hence, I'll successfully be able to log into the application that is vulnerable to this kind of an attack. Now, how do we fix this? Using sanitization. Like I mentioned, sanitization means escaping characters that can lead to the modification of the original query. So we are going to sanitize all the codes here, although we can sanitize other characters as well. So sanitization of codes in SQL generally is done by just doubling them. So that's what I've done here. And now this becomes where password is equal to this entire thing. So this is how the query is supposed to actually behave, to check if this entire thing, this entire sequence of characters in the user's input is being checked as the password or not. So that is done using sanitization. In almost all modern applications that you will see or create, you will not be facing this vulnerability because they all have sanitization built in. Well, then why am I even telling you about this vulnerability? Because not all the applications on the internet are created recently. Most of the applications on the internet use PHP, SQL, and primitive ways of validation, which is why they are vulnerable to something as simple as SQL injections, unless the engineer took care of that while building the application. Now, time for our first hands-on of the day of an SQL injection. So I will go here. The first one is SQL injection. This is the same repository, by the way. You'll find its link in the description of the video. And I am going to pull up the machine, the virtual machine. I'll run it using Docker. Okay, looks like the application has started. Let's see. Okay, so this looks like some social media site, www. I don't know what it is, but this is a typical authentication page where you have to enter a username or an email, it could be anything, and a password. Now, I know Mukul, one of the members of PyData, he is actually one of the most brilliant people in the fresher year. So he registered on this website recently, but I don't know his password. I know his username is Mukul, but I don't really know his password. So I am going to try to hack his account here, and let's see how it goes. I know for as a matter of fact, or maybe I don't. I am going to test the SQL injection vulnerability on this website, and if it is vulnerable, then it would allow me to log in. So let me first try some random password and try to log in. Okay, it says invalid username or password. What if I keep this empty? Still says invalid username, password. What if I try the same here? Still invalid. Okay, now let me open up Notepad so that you can see it better. Okay, so assuming the query uses double quotes, something like select star from users where username is equal to whatever I input here, and password is equal to whatever password I input here. So assuming the query uses single quotes, I have already entered the username as Mukul. So in the password, let me see what we can try. We can try this. So if I enter this particular thing in the password field, the query becomes this and the condition becomes true. As you can see, the condition becomes true, so I'll be able to log in. So let me try this. If it uses double quotes, then I'll do the same using double quotes. Let's just try to hack our way into it. So I'll enter that and I'll try to log in. Let's see how it goes. And there we go. It says hello and a logout button. So that means that I have successfully logged in to Mukul's account without knowing the password. And let me try one more thing. Let me log out and I'll enter this same thing in the username as well and the password. Let's try it now. Okay, so I was just able to log in as some random user or maybe no user at all without having to enter correct credentials. So even though I entered wrong credentials, it got validated due to this particular security flaw known as the SQL injection vulnerability. So this was the demonstration of the first vulnerability. Let me bring it down as we move on to the next one. I might need to clear the cache for this. Okay. Meanwhile, let's go on to the next vulnerability. Cross-site scripting, also known as XSS. So XSS is typically used to refer to cross-site scripting, which is yet another vulnerability that is due to lack of sanitization in the application's backend. So in SQL injections, we were modifying the internal SQL query executed by the application to get in touch with the database. In the case of cross-site scripting, however, we are going to do something else. We are going to exploit the client-side experience of the application because we are going to make the server send client-side code that is not supposed to be sent. So for example, you open Facebook, I open Facebook, I hack into Facebook, do something inside it so that when you open Facebook, you see what I have done instead of what Facebook should show you. And all of cross-site scripting does generally involve this stack only: HTML, CSS, JavaScript, and WebAssembly, because these four are the only things you can inject into an application when it comes to cross-site scripting, because scripts run on the client side. For example, if you open the website on your phone, it runs on your phone. Okay, if you open it on your computer, it runs on your computer. So you are making the website send something that runs on every person who opens it. Okay, client side scripts, they are all client side scripts. I'll give you an example. For example, make a comment. Okay, it's a website where you're supposed to enter a comment. So it says enter your comment and you say nice one. So when someone else opens the website, they see your comment there and it says nice one. Very well, you made a comment. Congratulations on the achievement. Now let's try something different. Okay, you are a little bit of a more intelligent person and you want to exploit the cross-site scripting vulnerability. So in addition to the comment, you said nice one, and after the comment, you entered this thing. Okay, you created a script tag. So a script tag is a tag in HTML, if you know about this. And everything interactive in the front end is HTML, CSS, and JavaScript only. So we can't deny that this would work unless it is being sanitized. So you open script tags, close them, and inside the script tag, you write some malicious client-side code. And then you make the comment. Someone opens the website and they see nice one. Where did this go then? Why can't they see this? Because this is a script tag. Of course, the contents are not going to be visible on the screen as a part of the document. Whatever is inside, either this gets sanitized or it gets removed or it gets executed on the client side or on every client side. Every client that opens the website is going to have this run on their machine. What about the rest? Where did this part go? Well, it gets executed on every machine that receives it. Now, how will we sanitize this? If you know about the XML standards, there are only two characters that essentially need to be escaped in any document. One is the less than sign and LT semicolon, and the other one is the and symbol itself and AMP semicolon. So these two symbols need to be escaped. Pretty much everything else can be gotten away with. You can also escape the space bar and an NBSP semicolon. So if it gets sanitized like this in the backend, or well, it generally does in modern applications, then this entire thing will be visible in the comment section. Now time for our second hands-on. I will spin up a website that is vulnerable to cross-site scripting and show you how it works so that you can avoid it. Let me try running it. And as I mentioned, I'm relying on the electricity. So if you suddenly can't hear or listen or see me anymore, the electricity is to be blamed, not me. Okay. Looks like I had already done some malicious changes which I forgot to remove. So let me fix that before I actually go ahead with the demonstration. Okay, so let me open the website freshly and show you what it contains. Okay, so this is the website that we are going to hack this time. Okay, it shows us, and meanwhile, let me keep the query window open so that I can show you some other ways as well. Okay. Okay, there we go. So this is the website. Okay, I am a regular visitor of the website and I am going to be trying to add my comment here. Maybe this is a movie comment site. Who knows? It could be anything. So let me try adding a comment. I add my name there and I say, loved the movie. Excellent. So my comment did get added here. Now we were just talking about cross-site scripting. So let me first try to see if this website is vulnerable to cross-site scripting or not. And how exactly are we going to see that? Just wait and watch. Let me try to enter another. Okay, why would I use my name? I would just say anything. And in the comment, this time I'm going to enter some HTML. Okay, let's try the B tag. You know, it is bold. So if this works, then maybe the website has the cross-site scripting vulnerability. Let's see. I make this comment. Okay, so it does look bold, which means this website could be vulnerable. Okay, let's try something different. Okay, let me look at the source code of the website. So for all its styling, it currently relies on this one file, style.css. And header h1. Let's try adding some style, some custom style to our comment. Hey, and now a style tag, and inside this style tag, this is just general CSS for those who know. So I'll say header h1 and let me set the color to something like yellow. Let's try yellow. Now let me add my name here, anything. So if this vulnerability works, then this header, this title of the website, this will turn yellow. Let's try. Okay, it did turn yellow. Now how was I able to modify the internal functionality of the application? In fact, if anyone opens this website, anyone in the world opens this website, they will see this thing as yellow in color. Because I was able to recognize that this website has this flaw, I was able to exploit it. And this is not all I can do. Okay, modifying the styles of the web page. What are we doing here? Show us some real hacking. Okay then, let me try something else. Okay, I don't want to be accused, so I'll use Mukul's name here instead. Why Mukul? Okay, why does Mukul have to be blamed for everything? Let's try Kanak's name here. And this time we are going to insert some actual script. Let's try. So I'll say I'll add an innocent looking comment. And now here begins the fun. So, I worked day and night so hard to develop this website, but Kanak wants to steal the credit. Okay, she wants to make others believe that she created the website instead. So she will do this. Okay, and then there we post this comment. And done. Now let's see how it is coming in effect. Let's first look at the source code. So the source code, the updated source code of the website, and in the source code we can already see this script tag is being directly inserted into the comment section. So anything that goes into the script is going to be executed here. And that is, well, if anyone opens the website now, let's say I open the website, it immediately says made by Kanak. So Kanak, congratulations, you successfully stole the credit of developing this website by exploiting its vulnerability to cross-site scripting. But that's not all that we can do. Mukul is even more of an expert in this. So he will do this, a script tag here. And he will say window.on load is equal to a function document.write. What do we write? Mukul hacked this. Let's try this. Let's hope it goes well. And there we go, made by Kanak. And Mukul owned this. Now what on earth just happened? Like, did you even understand what happened? Let's see. Let me open the source code again. So window.onload, this is just the JavaScript property that defines what is supposed to run after the window finishes loading. Don't do this, by the way. Use add event listener if you are developing a real application. And document.write, so whatever you pass inside will be written into the document, and the entire source code is gone. All we have is this, and this is happening on the client side. Anyone who opens the website will only be able to see this made by Kanak, and as soon as we do this, Mukul owned this. Mukul hacked this because he was able to get his way through cross-site scripting and made it execute something that wasn't supposed to be executed. Okay, that's not the end. Let's try something else. Okay, I want to show you one more way to exploit it. Let me open the website again, a fresh website, unhacked. Now I'll go with it. Now I am an even bigger culprit, so I'll do this. A script tag here, and inside the script tag I'll do this window.location.reload. So I'm calling this function window.location.reload. Now JavaScript developers might know, others who don't know, calling this function will reload the current web page. Now when someone opens this web page, this function will be called, the website will reload. Then again this will be called, again it will reload. So this will be a case of an infinite reload. Once I make the comment, the website will be totally unusable by anyone. So done, and it is already reloading a lot. See, I open it in a new tab, I try to do anything, I can't really do anything because it keeps on reloading itself. Why? Let's look at the source code. Because okay, in fact, by reloading itself, it made the same comment multiple times, so now it is reloading even more. And if it continues happening, the browser will hang, so I'll close it. And there, that's how I just showed you yet another injection vulnerability, which is cross-site scripting. and I hope you learn from it. Never develop an application that doesn't sanitize user input, otherwise this can happen. Let me bring down the containers, and let's go ahead with the next topic. Okay. The next thing we are going to discuss here is shell injection. Shell injection, now what is a shell? The system shell, the system command line, the very thing that exists below the GUI, the graphical user interface that we see in our operating systems. There's something that runs below it. That's called the shell. Now, when we have the command line, then we can do people who operate through the command line primarily call themselves the power user of the system. So we are going to see how we can develop applications, command line applications that are not vulnerable to shell injection. There are very common mistakes people do. For example, a command line application that calls something else through the command line with some parameters in Python, in JavaScript, anything. So there are multiple ways to do this, either using a child process or a sub process depending on the programming language, or simply using the system command execution utility built into the language and giving it everything that the user gives as an input. And that, like I mentioned, without sanitization, limits your command line application to a particular format of inputs only, and anything else would either crash it or cause it to behave differently. And if you are innocent enough, you might actually end up damaging your system, okay, accidentally. You don't even know it is happening. New engineers, what does this mean? Okay, every engineer who gets into college generally starts with the language C, C++, or Python or Java, developing command line applications, very simple, like hello world, enter your name, hello, that kind of applications. And their applications are generally vulnerable to this. If they try to go advanced without proper sanitization, then this happens. Now, whatever gets injected could either be through standard input or command line parameters. I'll show you. So for example, assume a command line utility that searches for something that I tell it to. So I enter param. So it is supposed to search for param and give me the results. So it internally executes yet another command line application, which is called locate, with the parameter param. So it says locate param. It executes locate and with the parameter param. Looks decent to me. It works as well. However, what if I enter this into the input? Doesn't look decent at all. But this is just an attempt to see how vulnerable the application is. Param and rm / important.txt. Now, the rm command, if you know about this, is used to delete files in the bash shell. Okay, and if somehow this gets executed, even accidentally by the application, then this particular file, if it exists, will be deleted. So this directly gets injected in there, and now it says locate param and remove this thing. So after the successful execution of this command, this will also get executed and this file will be deleted. Now, of course, someone else will not be able to use this technique to hack into my PC or something like that. But let's say the command, the particular application in which we are injecting this input, has administrative privileges but does not require authentication. In that case, things might go not as intended, and we might have unintended data loss by mischievous people who just have access to the non-privileged version of the system. So that is why it is important while developing command line applications to not be vulnerable to shell injections. Now, how do we sanitize this? In this particular example, we are simply quoting this entire thing, and that is enough to sanitize it. This command will not be executed. This entire thing will be taken as an input, as a parameter for this command, and will be used to search for this entire thing. And if it finds anything, okay. If it doesn't, still okay. There's no unintended data loss. Nobody is hacking into the system. Very well. And again, this is something that new engineers need to be take care of, and time for our hands-on for shell injection. Before starting the example, I would like to show you the source code of the file. So this is a very simple command line utility. I decided to name it LLA, and inside this you see there's a main function. It receives a command line parameter and it executes this ls-1, a space after that, and then the command line argument, whatever I'm going to enter. And this particular program doesn't do any sanitization or any clarity check of the input before adding it to the string, which is why it is vulnerable to shell injection. And let's see how. So for this, I won't be pulling up any Docker containers. Let me go to my Ubuntu. So also we have a make file here, which clearly tells us what it is going to do. So I'll simply install the utility. Sudo make install. And looks like it has been installed. Now let's see how it works. Let me see if okay. So we already exploited it quite well, but either ways, let's run it and see. LLA. So it listed the files in the current directory, the make file, the readme file. So whatever files we have in the current directory, let's go to some other directory. LLA. So it mentioned all the folders in the current directory. This is also very nice. It mentioned everything. Now, what if I do LLA and pass a string argument that says dot. Dot is the current directory, and maybe a semicolon and echo Mukul is dancing. Okay. So this time it still did list the files in the current working directory, but it also listed Mukul is dancing, but there is no file named Mukul is dancing. So why did it get displayed here? There's no file named Mukul is dancing because this echo command got executed along with whatever command was intended to be executed by the application, because the input was not sanitized. Okay, generally if we add a semicolon, this indicates end of the current command and the next one. Okay, but that didn't happen here, and instead this entire thing was added to the command inside the original string, and it got executed, which is why we got this. What else can we do? LLA dot the current directory semicolon and maybe the id command. Okay, so now I got this huge output of the id command as well. And let's say I was not privileged to run the id command myself, but I was privileged to run this command, and this had administrative privileges. I would still be able to run the id command without having to run the id command directly, just because I have access to something that is vulnerable to shell injection. So this was the shell injection vulnerability, and we need to be careful about this, especially if we are developing command line applications. Let's go ahead. Service isolation. So this vulnerability talks specifically about authentication. Okay, authentication needs to be as back-end as possible and as less front-end as possible. This is the rule of thumb when developing applications. Maybe the application will become slower, but at least the authentication would be reliable. The oversimplification of authentication done by full stack developers who start developing new applications is the reason why service isolation becomes a vulnerability. We want to isolate the service to authenticated users, but even unauthenticated users are able to access the service by hacking the front end itself and not even touching the back end. To resolve this vulnerability or create applications that are not vulnerable to this, we need to ensure good authentication. We need to make sure that we are authenticating legitimate users correctly in a manner, in an as much of a backend manner as possible. Again, new engineer folks tend to make this mistake because they don't really understand the difference between front end and back end, and how much front end can be exploited by the right people who know how to do this, and hence need to be careful. Time for our hands-on for service isolation, and I'll show you a very vulnerable example. Although I have seen real applications being built by big companies who are vulnerable to this particular exploit, and still nothing is being done about that because not too many people are exploiting it, but it is common. So make sure do the authentication in the backend, not in the front end. For this one, I'll be pulling up a container. Okay, docker compose up -d. If you have any questions, by the way, you can drop them in the chat. I'm constantly looking at the chat and I will try to answer them right away as I see them. And as Lakshya mentioned, the use of sub process. So if you are ever running shell commands through Python, always use the sub process module, built-in module for that. Don't rely on os.system. It is very dangerous, Python developers specifically. Let me open the website. Okay. It didn't refresh properly. Okay. Food center. So this looks like a food center website from where you can get what? Food. The world's best food items are sold here. Okay, what exactly is sold here? Let me go to the buy tab. I can see two tabs, home and buy. Let me go to the buy tab and let's see what we can buy from here. Proceed to buy 30 samosas for 300 rupees. 30 samosas for 300 rupees. Let me do some calculation. That means 10 rupees for one samosa. Even in regular shops, you'll get one samosa for somewhere around 7 rupees, but 10 rupees for one samosa, and this is small samosas, that's a lot. Okay, but either way, if I have a choice to, I can only just click buy here and buy 30 samosas for 300, or maybe I will try to look at the source code of the website. Okay, very small source code for such a big e-commerce application. I'm being sarcastic here. So there's a script file attached here, purchase.js, and the name of the script file is making itself too obvious to me that this is the file that handles the purchasing. Let me look at it. Okay. So I can see a number of interesting strings here. Okay. Like I said, never use window.onload, always use this. You don't want to overwrite any existing functions. Window.location.search. What is window.location.search? Let's look at that through the console. Window.location location.search looks like an empty string to me. But I can see that it is initializing a new URL search params object and looking through its entries. So it is trying to see what search parameters are added. So for example, if I add a parameter, Mukul is equal to 1 and Krati is equal to 2. Now let me try to look into the value window.location. Okay, so now I see the query parameters added over here. Mukul is equal to 1. Okay, now it is trying to initialize an URL search params object. Let me try doing that. New URL search params dot entries, right? Entries. Okay, very bad iterator. I don't want an iterator. Let me see if I can get an array out of it. Okay, an array of 2 elements, which both elements are also arrays, Mukul and 1, Prati and 2. So now I understood that it is trying to retrieve the search parameters of the website. Very well. Has own property. Okay, now it is creating an object from the entries. So key value pairs. Does it have a key named premium? If it does, do this. Else, don't do this. Okay, so it is going to look for the premium parameter in the website. So let me try. Okay, let's try adding it. Premium. And I'm not going to give it any value. I'm leaving it empty. Let me just add it and see what happens. Interesting. So the buy option is gone, and now I see a button labeled premium. Interesting. So I just made a slight change in the way I look at the front end, and suddenly I have access to the premium version of the shop. 360 samosas for free. So looks like this was a feature only available to premium users, and I was able to become a premium user myself just by exploiting the vulnerability of the front end that allowed me to become a premium user. And here I am getting 360 samosas for free. Earlier I was getting 330 for 100 rupees. So much better. Let me order them. Very well. Now I'll get the samosas and enjoy them alone. So I just demonstrated to you very poor authentication, which is being handled entirely through the front end. But this is not usually the case. We mostly rely on the backend for authentication, but still often we develop applications that rely too much on the front end for authentication, and we need to be careful about that. I'm bringing it down. Meanwhile, let's continue. Done with service isolation and validation as a concept, let's move on to deception. Now this sounds filmy. Deception means pretending to be someone or something that we aren't. Okay, we might be deceiving the system, or we might be deceiving the end user. Both have their own examples, and we'll discuss both in the workshop. Deception means acting as a trusted entity, whereas in reality we are a malicious entity. We are making the system or the user believe that we are supposed to be trusted, that we can be trusted, whereas in reality we can't be, because we are malicious. We are planning something heavy, something bad. And how exactly do we protect ourselves or our system from deception? Awareness and precautions. Precautions in terms of system architecture, and awareness in terms of being human. Okay, we need to be careful that we are not being deceived in the online or the offline world. So let's go ahead with the examples that should make it clearer. Phishing. So the first impression of this word is phishing. Fishing as in capturing fishes out of a river to eat or to sell in the market. How exactly do we fish? We give them something that looks like food but is actually trap for them. Well, that is exactly what phishing does to the users. It pretends to be a trusted system, whereas in reality it is the opposite of that. It looks like a trusted system because of a similar user interface, and the end user is being deceived to believe it to be a trusted system, and they enter their credentials or do something that they shouldn't, and their information gets stolen by someone else, someone who managed to create a stripped down version of a trusted system that looks like one but isn't. Okay, mostly this is used to do the stealing of credentials such as passwords and usernames. Time for yet another hands-on. Let's go ahead with it and I'll show you what I mean by this. Okay. So for this particular example of phishing, I'll be using something known as the social engineer toolkit, also known as SET. You'll find it on internet. It comes pre-installed with Kali if you have it, and it can be used to do a number of things. You see the social engineer toolkit. You might look it up. You might want to look it up on the internet. It's also on GitHub if you want to contribute to it. So I'm starting it. Number 1, number 2, number 3, number 1. The IP address. So I'll make it localhost because I'm running it in a Docker container. I know it is localhost /8080. If you host the phishing website on something else, you'll enter the address of that here so that it knows what to forward the requests onto. Okay. Of what? Maybe Google. Let's try Google. Okay. So it is running. Let's see. On port 80 of the container, not actually. Let me try. Okay, it still shows me the food center. Let me do a hard refresh. Okay. Sign in with your Google account. This does look like Google's website, doesn't it? Although not completely matching the current UI, it does look like a web page from where I can sign into my Google account. But it is not. First of all, look at the URL. It says localhost /8080. Far away from being anything Google. It says localhost /8080. Come on. This is not the Google sign-in website, definitely. The second thing is this. It doesn't show me a lock. Okay. A safe website. Okay. Here I see a lock because it is GitHub. This lock only means that the website has a valid SSL certificate, a verified SSL certificate, and a verified SSL certificate also doesn't necessarily mean that a website is secure. It just means that the communication between the website and the client is encrypted. So mind my words, a lock sign here does not mean it is safe, okay? Does not mean you are in the right hands. I can create a fake website with a lock sign and make you believe that it is right. But don't get fooled by the lock sign. We have an organization named Let's Encrypt that has made getting SSL certificates way easier for everyone. And it is for the good, but people might exploit it. So be careful. A lock sign doesn't mean safety. Remember that. The second thing is, okay, I must mention this. This is very important. So many of you don't realize this. When we sign into Google, we have something like accounts.google.com. Okay. What if you see a website like accounts-google.com? This is nowhere close to Google or anything Google can monitor. This is a separate domain name. If someone buys this domain and hosts a phishing website on this, you might never be able to tell the difference. This will also have a lock icon and everything, maybe some extra jargon here that you don't understand, but it is still fake. It is not real at all and not something that Google is to be blamed for. So be careful while going through web pages on the internet. Don't get phished. Please don't. Also, if a malware enters your system, if someone hacks into your system and modifies the hosts file in your system, be it Windows or Linux, there's a file named hosts that takes precedence above the DNS. So if someone edits that, then you might actually be navigating to this and still be led to some malicious website. So be careful. Okay, that is why be careful with your system. It doesn't get hacked, because if it does, then you are going to lose everything at some point. Okay, so let's see how this phishing website works. It is a phishing website. I'll try entering my credentials. I'll not enter my actual credentials, of course. So I entered some of them and I click sign in, and weirdly enough, it takes me to the Google homepage. This is not the expected behavior of the sign up page, but either ways, let's look at the command line And whatever I entered there, I can see that here. My email address, me@paramsit.com, and my password, which is just my password. That's what I entered. So now I have the credentials here, and I can send this, I can host this and send the link to anyone and ask them to authenticate falsely. They will actually be led to the original authentication as well. They will never realize. And I would still have the authentication details because I ran a credential harvester through the social engineer toolkit. And if I end this will be saved inside a report from where I can take the credentials that are being harvested. And this is just one of many examples, many types of phishing attacks. I just showed you a very small example. Now we have Lakshya in the chat here. We have Lakshya in the chat, and I had a discussion with him recently, and he mentioned that there are some websites that offer you to host phishing on their servers, and some people try to act cool, like host their own phishing website on some websites, on some random services, and then try to get their friends' credentials by fooling them. But you are not hosting it, someone else is hosting it, and you never know how they are using the credentials that they are acquiring and giving to you as well. So don't get into such things, please. I'm telling you, be safe, be kind to yourself, don't get into trouble for nothing, and think twice before doing anything or trusting any service on the internet. Let's move ahead with the next one. So phishing was the first example of deception attacks. The next one is user identity spoofing. So currently we pretended to be a system. This time we are pretending to be a user. Last time we were looking at how we pretended to be a Google homepage, Google sign up page, whereas in reality we were not. This time we are going to be pretending to be a user, a trusted user, whereas in reality we aren't a trusted user. And we won't be stealing any credentials or doing any validation here. We are going to be doing something totally different, and I'll show you what. The system in this case is being misled. So if you remember the last slide, the end user was being deceived. This time the system is being deceived. And how exactly am I pretending to be an authenticated trusted user? Because I have stolen authentication. And this could be something as simple as a stolen password, but this could be many other things as well. What could that be? Well, it will be clear with the hands-on. Stealing cookies. Now, I am not Lord Krishna. I am not going to go steal cookies. I am talking about the cookies that are stored in your web browser. Cookies are a term given to credentials and authentication information stored into the web browser by the server side of applications. And it stays in your browser, so it can be stolen very easily. That's what I'm trying to demonstrate here. So let me bring up the container. Okay, so the application has started. Let's look at the application. Okay. There we have it. Top secret tasks. Okay, what are the top secret tasks? The government relies on these secret tasks. Okay, must be really secret, right? However, it says it requires us to enter a security key, a secret key. Now, I don't know what the security key is. It says authenticate. Doesn't work. Let me try entering something. Doesn't work. Log out. Now I didn't even log in, so what's the point of logging out? Never mind. Let me try to click access. Error retrieving records. Did you authenticate yourself? So far what I have learned about this application is it requires me to enter a secret key and authenticate myself. Only then will I be able to access the top secret tasks, which is supposed to be seen only by authenticated users. Now, let's say my friend, okay, I have a friend who works in the government, and my friend has the secret key, but my friend won't tell me the secret key. However, my friend has logged into their machine using the secret key, and I asked them to bring tea for me, and I have their machine in my hand till that time. What can I do to steal the credentials? So, okay, assuming this is my friend's machine, and my friend knows the secret key and is authenticated. Okay, these are really vague tasks: eat food, go for a walk, not something good for the government to rely on, but either way. So my friend is authenticated, and I want to have access to this secret information as it is updated and be able to authenticate myself into the website even through my system without knowing the secret key, because of course I can't get the secret key, my friend won't tell me, and I don't know what they entered there. So they have gone to fetch some tea for me. Meanwhile, I'll open the console in their browser, go to the application tab, go into cookies, and there are so many cookies here, but I'm interested in these two in particular, session and session.sig. In real applications, they might be named differently, so don't blame me for that. Session session.sig, and then I'll quickly close that, take a screenshot, take a picture of this with my phone, and then close this as well. Okay, I'll take a picture and then close this. Now my friend doesn't know what just happened, but I stole their cookies, not literally cookies, but I stole the cookies from their browser. Now let me go back to my machine. Okay, let's say this is my machine and I want to authenticate. I want to authenticate. I don't know the secret key, so I'll try to fool the system by making it believe that I am my friend. I am already authenticated, and that's what I am going to pretend. How am I going to do that? I'll go to the application tab in my own computer's Chromium browser, and I'll enter the cookies myself. Let's try that. And since I have the screenshot, I know it. I'll get it from the photo and I'll enter these manually. Session.sig. Done. So I manually added some cookies myself, which correspond to my friend's credentials, thankfully, who was careless enough to go get tea without logging out. So now let me try accessing it, and voila, I am able to access the tasks list without having the secret key in my hand. How funny is that? Just because my friend gave me access to his device for a very short amount of time, I was able to steal my friend's credentials without having to know the secret key or the credentials themselves. I just stole their cookies, and now I can authenticate myself into the application without even knowing the credentials. And okay, maybe if my friend logs out and logs back in, then the cookies might change. The earlier cookies might be invalid and I won't be able to access these anymore. Then I'll have to steal the cookies again. But still, it is a possible way to steal authentication and be able to fool the system to believe that we are an authenticated user. So how exactly do we avoid this? Let's talk about that. Also, cookies. So can we only steal cookies? Can nothing else be stolen? Well, a lot can be stolen. We'll discuss after this. Are cookies the only thing that can be stolen? I bet not. A lot can be stolen, and not just cookies. Your system contains so many things that can be used to identify your credentials that you just need to be careful before letting anyone else get access to your device in order to protect your authentication information. So the authentication information of users stored on the client side can be in many forms, keys for an example, or it could be stored using the local storage API or indexed DB within your browser. And what exactly will be stored? It could be the JSON web token, which is one of the most modern ways to authenticate. Or if it is an app, not a website, an app, then it could be the app's internal storage format. So that file can be stolen in order to authenticate as you, whereas in reality it is not you. Now MongoDB's version key __v. This is for the developers. So developers who use MongoDB in their applications backends, you can use this to validate JSON web tokens in your application and ensure that the latest authentication is the one being considered, so that after any changes made to the user's information, the earlier cookies or authentication doesn't work anymore. So this is something interesting for you. Keep your devices away from the wrong hands. You never know how much the person in front of you knows about getting information out of your system. So be careful, keep your devices away from the wrong hands, from in fact anyone's hands. And if you are lending your device to anyone, make sure you are following security measures and not letting them access anything that can allow them to steal your credentials. Okay, let's move on to the next section, which is cryptography. Protecting information by coding it, by transforming it, by coding it. The point of cryptography is to make sure that only the one intended, the one the message is for, is able to comprehend it. Now this doesn't necessarily mean sending a message. This could be having the message validated, or it could be just that the system understands it and the user doesn't. It could be anything. And there are 4 terms here: encoding, encryption, hashing, and obfuscation. These 4 terms correspond to different things, and we are going to differentiate between them. A large number of people are often confused about them, so we'll discuss them after this slide. How exactly do we ensure that we are able to successfully protect information by coding it? We must, for that, we must use an algorithm that is reliable and complex enough for no one to understand or figure out or break. Encoding, encryption, hashing, and obfuscation. Let's first distinguish these terms so that we can go ahead. Encoding means keeping the data usable, just modifying the format while keeping the data the same. So we are not modifying we are not causing anything, any data loss. We are not hiding anything. We are keeping the data as is, just changing the format. Okay. For encryption, the purpose is different. Keeping the data confidential. Confidential as in someone who doesn't know how to decrypt the encrypted version doesn't know what the information is. So ensuring data confidentiality is the purpose of encryption. Hashing. Hashing means enabling data validation. So we are not letting the other person know about the data as well. We are assuming the other person has the data and they just want to check that the data that we sent from our side is correct or not. So data validation. They don't know about the data as well. They just have the hash. So they can match a hash of the given data, or they can take the hash from us and match a hash of the data that they have on their end. So this is just data validation, hashing. I'll explain it further. Don't worry if it is confusing for you right now. Don't be overwhelmed. Obfuscation. Obfuscation is mainly done to code. We don't want to be comprehensible to the wrong party. We don't want the wrong party to understand what we are trying to express. We just want to be understood by the system that is supposed to run our instructions. And we can make them as complex as we can without being inefficient, just making sure that only the system is able to understand it and not someone who shouldn't. Okay, let's start with encoding. So I'll use a very simple example. There's the word dog, D-O-G. 3 letters, it is a word, dog. I have encoded it into this format. So the UTF-8 values corresponding to each of these letters D, O and G, I have written down them in the binary format, and now I give this sequence to you, and you know what to do. You know, okay, these are binary numbers. Let me write them down as decimal and find their corresponding characters in the UTF-8 table or the ASCII table, and there you have it. You can decode it into dog once again. So this was a very simple example of encoding. Anyone can decode by reversing the encoding process as long as they know about it. Now we have encryption. We'll do it with the same word. I don't know, I just love dogs, although I'm scared of them. So I encrypted the word dog using any particular encryption key, and now I have this thing, QBT. Now no one can look and tell, okay, QBT means dog. Also, no one can directly see and tell that this is encoded, because it's not. It is encrypted and it requires a particular key to be decrypted. So no one will be able to get the word dog back without having the decryption key, which in this case is 13. I just did a rot 13 here. So without 13, they won't be able to decrypt dog from QBT. So anyone with the key can decrypt. Anyone who does not have the decryption key cannot decrypt it. Now the encryption and decryption keys could be the same, might not be the same as well. It depends on the encryption algorithm. It could be that encryption is done using a different key and decryption is done using a different key. That is usually the public-private key encryption decryption that is done in SSL. Next we have hashing. So we'll again use dog here. Don't worry, for the next example I can't use dog, but this one here we have dogs. So we take the word dog and we get its hash. So this is some particular hashing algorithm. We are not getting into which algorithm this is, but we will after a while. So we have a hash here. Now the purpose of hashing is not to make it impossible to get information back from the hash. So if I say that I give you this hash, try to give me back the word, it's not impossible, but it is highly unfeasible. It is highly computationally expensive for anyone to be able to get the word dog back from the hash. Well, then why are we even creating the hash? What is the purpose of creating the hash? So that we can validate. If we have a word dog here, we can generate its hash and compare the hashes to check, okay, if this hash is correct, if the word dog was the intended sequence to have the hash for. So anyone can hash the word dog again and match it with the given hash to verify it that it indeed is the hash of the word dog only. Okay, no one will be in a feasible manner be able to get the word dog back, but if they already have the word dog, then they can validate it using this hash. Time for obfuscation. This is something we generally do in our coding practices. So this is specifically to specific to programming. This is some arbitrary programming language where it calls the display function with 1 plus 2. So 1 plus 2 is 3, and calling the display function with 3 as the input, this will display 3 onto the screen. So that is looks quite obvious. Just by looking at the code, someone can tell, okay, this displays 3. I'm going to obfuscate it, and now it looks like this. This is way more complex for someone looking at the code, but for the system, it is not that different. It might be a little less efficient, but it's not that different. This piece of code does the same thing that this piece of code does. How exactly? Okay, let's see. X is equal to display. So we are assigning the function display into X, and then we are calling X. So we are simply calling the display function, except we are doing it in this manner to confuse someone who is reading the code. And what are we passing inside X? This is a hexadecimal number divided by itself plus, so any number divided by itself as long as it is not 0 gives 1. So this entire thing is 1. 0x ffff divided by itself, this is 1 plus 2 times exponential of 0. So e to the power 0, what exactly is e to the power 0? It is 1. 2 times 1 is 2. So 1 plus 2, that again gives 3, and calling x, that is display with 3, again displays 3. So this sequence of code does the same thing as this sequence of code, but it is obfuscated, which makes anyone reading the code harder to understand what the code does. And this is often done to protect our application from being modified by people who shouldn't. And often we want to protect our code from misuse, then we do this. The code still does the same job, it just makes it harder for someone reading that to figure it out. Okay, here we begin with our first example of cryptography, the Caesar cipher. So the Caesar cipher is one of the simplest cryptography algorithms that we can discuss. It is a simple form of encryption that is done mainly on Roman characters, Roman alphabets that we use in English, and it uses a numeric key as the encryption key. If you can hear birds, then that's because there are actually birds behind me. I can't do anything about them. Maybe I can, but okay. So we have this sequence of alphabets all the way from A to Z. These are all the alphabets in the English language. And if I shift them all by 1, so I just shifted them all one character to the right, and Z came to the beginning. So we just rotated them by 1. So that is why it is rot 1. Similarly, I can shift them twice, rot 2. So if I have to write param, so instead of P, I will write O. Instead of A, I will write Z. This is the rot 1 encryption. If I do, instead of P, I do N. Instead of A, I do Y. That is rot 2 encryption. So using any key as the basis, we are encrypting text in Roman alphabets. So rot 13 in fact is a particularly well-known case of Caesar cipher, because beyond 13 you can express the same using a negative number as well. 13 is just the half of 26, which is the number of alphabets we have in English. So that was Caesar cipher, and now we will do a hands-on where I will demonstrate to you how it works and how it actually looks like. So for this also I won't be getting any new containers. So for Caesar cipher, I wrote a very simple application. Okay, by the way, where was I with the other example? So this one is also a non-container example, and I'll be using my Ubuntu machine to demonstrate it to you. I have written a very simple C program that does the encryption. So I'll be showing to you. Okay, we have this file text.txt, and it says something like URYYB GURER. So we don't understand what this is, and we are assuming this is a Caesar cipher using any particular number as the key. So let's try this. Done. So now we have this command line utility called cdec. Now we can use this to decode that. So we have to mention an order, the key that represents the encryption. So let's try 1 maybe with the text file, and we get something, but this is still unrecognizable. So maybe we use the wrong key. Let's try 2. Let's try something larger. Let's try 6. Let's try 10. So it doesn't look like we are getting any closer. Aha! So when I use 13, since rot 13 is a very particular use case, we get hello there, what's up? So we just shifted the characters, the alphabets in English, and we got ourselves a comprehensible message out of something absurd like this. So this was an example of the Caesar cipher. Let me uninstall it now. I always forget to uninstall. Meanwhile, let's go back to the slides and continue our discussion from there. The next example is of base 64. Now base 64 is a very well known encoding algorithm, not encryption, encoding. It just transforms information from one format to the other, but the information remains the same. Okay, the information does not change, it is still the same thing, but it is encoded. So let's get back to dogs. So our initial data is dog. We'll break them into bytes. So each character is of 8 bits or 1 byte, and we are representing each character using a number. So 100, 111, 103. These are the numbers corresponding to these characters D, O, and G. Now let's write these numbers in binary form. So 100 becomes 011001000. 111 becomes this, 103 becomes this. Now these three binary numbers, we are going to join them. We are going to concatenate them like this. So these are 8 digits. You see, 1, 2, 3, 4, 5, 6, 7, 8. 8 digits, 8 digits, 8 digits. Now we are going to concatenate them and break them into 6 digits. 6, 6, 6, and 6. What if they don't perfectly break into 6 into parts of 6? In that case, we will pad the last one with some extra zeros to make it 6. Okay, so we have divided it into sequences of 6, and we'll get the corresponding numbers from these binary digits. And base 64 follows a particular pattern, a particular code, which you can find very easily using the internet. Let's go to Wikipedia and see. So this is the table, and we have the indexes both as decimal and binary, and we can use these to figure out what is the encoded form. So we have 01, 001, 01, 001, 01. Where do we have it? Okay, 011001. So that's what we had here. So it will be Z 000110 000110 G 111101 111101, looks like 9, and then the last one is 100 100111. I said 100 100111, which is N, small lowercase n. So that is the base 64 encoded version of the word dog. ZG9N doesn't look anything like dog, and these are 4 characters instead of 3. So looks like the size has increased, but it hasn't. We are just looking at the same data in a different manner. So this is base 64. Time for a hands-on. So what we just did was quite a hands-on itself, but I have written a very simple C program that does base 64 encoding. You might want to have a look at it later in the repository if you are interested in C programming, but I'll demonstrate it to you. Okay, so looks like I just installed a utility called B64, and we can use it to both encode and decode data. So let me write Mukul and send it to this. Okay, so Mukul is encoded like this. This is how Mukul encoded in base 64 looks like. And let me try decoding it, and we have Mukul back. As we can see, we have Mukul back. So we have a secret.txt file here that has something that looks like a base 64 encoded sequence. So let's try to decode it. p64-d secret.txt, and we decoded some useful information. It says user is equal to Swapnil, preference is equal to dark, entry is equal to okay, Param, dark, hello world, Ritesh, light, badhiya. So this is some information, maybe some applications internal storage format that uses colons and commas to separate information, and it has stored something here. Looks like not something very useful, but it is base 64. It was base 64 encoded, and we decoded it using the utility. Let me uninstall it and get back to the discussion. Okay, so that was base 64 for you. Now we have something interesting, something many of you might find interesting: hash cracking. Now, passwords and other credentials are generally stored in the form of hashes in databases, or anything that can't be used to get the password back but can be used to validate the passwords. That is how user information stays secure. That is how no one, even not even the system administrator, can know what the user has entered just by looking at the database. So hash cracking is the process where we reverse the process of hashing. Okay, if we take the hash and try to determine the initial value, but I just mentioned a while ago that it is impossible. Then how are we going to do it? Well, I didn't say it was impossible. It is quite impossible, but it is just highly unfeasible. It is so computationally taxing that we don't really aren't really able to do it generally. But it is possible if you are if you are allowing around 300 to 400 years to pass, then you might easily be able to crack all the hashes made using English alphabets, lowercase English alphabets of a particular length. So it is possible, but that's quite a long time, 300 years. You might yourself not be alive till then. So for uncommon and long sequences, this is not feasible. Why uncommon? Because for common sequences, even slightly longer ones, we can perform a dictionary attack. Okay, a dictionary attack as in a file that contains some common passwords, and then we try matching their hashes with the hash that we retrieved from a database and try to figure out the password. So these are some of the popular hashing algorithms: MD5, SHA-1 and SHA-256, out of which two have already been known to have collisions. What do I mean by collisions? One hashing algorithm giving the same output for two different sequences is known as a collision, and these two are known to have suffered collisions, but SHA-256 has not been known to have any collisions till date. Although as our computational systems get more powerful day by day, at some point we will have collisions within SHA-256 as well, I suppose. Let's see, we never know. So do we have the hands-on already? Okay, time for the hands-on for hash cracking. So let's get into hash cracking, and for this example I'll be using a tool called Hashcat. Many of you might have heard about it. It is used for hash cracking. Mind it uses the GPU, so it might lack support in your device because it has really high requirements, and I'm also willing to risk it. So let's go ahead. There was a web application, by the way, some social media application, not really social media. It was a UPI application, and I registered myself on it, and along with me, two other students also registered. From the first year, we have Khushi and Palash. So I, Khushi and Palash, the three of us registered into it, and we were pretty happy using it. But someone stole the database. Okay, and this is the database, users.db. Someone stole the database, which was an SQLite database, and now they are trying to break into our password. They are trying to find out our password. But don't worry, the app that we were using storing our password in the form of hashes. So I, Khushi and Palash are quite fearless about having our passwords leaked. So we are pretty fine. But should we be? Let's see. So let's say I am the hacker. I am trying to read the database in read only mode so that I don't damage it. Okay, so let me see the tables. So I see two tables, users and wallets. So I assume that user authentication is stored in the users table and wallet authentication is stored in the wallets table. Let me look at the schema. Okay, so through the schema I can tell the users table has two columns, username and password, and the wallets table has a username and a pin, and the username is a foreign key referring to this, and a pin for the wallet. Interesting. So I'll run the query, select star from users. Okay, Param, Siddharth, Khushi and Palash I can easily tell, but what is this? Looks like a hash, and this indeed is a hash. More specifically, this is an MD5 hash. How do I know? Just out of experience. I know this is an MD5 hash, and I can tell because I've seen enough hashes in my past. If we don't have this information, which hash it is, then it becomes twice as hard, because now we have to figure out what hash this is. But currently we have that figured out, so we can try to crack these hashes. Okay. Meanwhile, select star from wallets. So let's see what we have in the wallets. Okay, we still have the same usernames, but we have some longer hashes. So these hashes are definitely not MD5. These are SHA-256 hashes. So these are also hashes, but they are SHA-256 hashes, which are much more secure and reliable than MD5 because they don't have collisions. But still, if I, Khushi or Palash, any of us was foolish enough to use something common for our credentials, then it will be easy to hack through. So let's try. Let me first get the information out. So the output, let's say for the passwords, let's do passwords.txt. Select password from users and get the output back to standard output. Let's look at passwords.txt. Okay, now we have the hashes from the users table here. Let's do the same for the other one. What else do we have here? Pins.txt. Select pin from wallets. Now you see I didn't capitalize this because SQL queries are case insensitive, so I can do that and get the output back to standard output. Let's look at pins.txt. So now we have all the hashes from the wallets table here. So now we are going to track these hashes, and as mentioned, we are going to be using hashcat. Now hashcat has a concept of pot files, so it stores the previously cracked hashes in the pot file, and I want to have a fresh start in front of you, which is why I wrote a tiny script to delete the pot file, and I'll do it fresh for you. So hashcat, let's look at the help. And for an application that uses the GPU, it does take quite some time to even show help. So let's wait for it. If you have any questions, you can ask. So far, I can't see any questions, which means you're getting it well. Okay, we have the help here. Let's look at it. Let's look at what parameters we can pass. This is a lot. This is so much. Okay. So -m for the hash type. So if we know what hash we are trying to crack, we can mention that here, hash type, and -a, attack mode. What kind of attack we are doing. So I have a file, common.txt. This common.txt file has 93 most common passwords. Okay, and I am assuming that Param, Siddharth, Khushi and Palash are foolish enough to use any of these as their passwords, and I'm going to try to crack them. So let's try this. So this, by the way, is a dictionary attack because I have a prepared list of words that I'll be trying one by one. So this is a dictionary attack. So the attack mode will be dictionary, and Here we call that, let's see, straight. So we'll be using D0 for that attack mode. And what kind of hash are we cracking? Well, for the password, for the passwords.txt file, we are going to be using MD5, which is 0. The hash mode is 0. And what do we have for SHA-256? We have SHA-256, we have, okay, SHA-3-256. No. We are looking for SHA-2-256. This is 1400. So we are going to 1400. Did my voice just vibrate like a robot? I felt that. Okay. 0 and 1400. Let's keep that in hand. The parameters, let me look at that again. And let's begin cracking. -m for the hash type. Okay. Hash cat -m. The hash type here is MD5. So 0 -a attack mode. That is straight because we are using a word list. And the output is going to be stored in a file in the current working directory. Let's store that in passwords cracked.txt. Okay, let's just do that. And the first parameter, I believe, is supposed to be the passwords.txt file. I'll check that if I'm wrong. And the second parameter will be the word list, okay, which is common.txt. So if I entered everything correctly, let's go ahead and see it track the passwords from the hashes. Okay, so it got in touch with the GPU and it generated a passwords-cracked file. So it was successfully able to crack each of these hashes because these hashes were of some of the most common passwords in the world, like password, QWERTY, and test. These are very common passwords and very easy to crack because in a dictionary attack, and that's what I did right now. I used hashcat and it was able to reverse these hashes by matching the hashes with the hashes of each of these common passwords. So it successfully found them to match, and now we have 3 matches already. Let's try the same with the wallet pins. So let's do pins. However, the hash type here is supposed to be 1400 because it is SHA-2-256. We remember that. So let's do that. And first, I find it to be surprisingly fast. Usually when I have to use hashcat, it is way slower. Okay, so it generated the pins-crack.txt file. And here also we have the pins, the wallet pins cracked. Samosa, QWERTY, chocolate, such simple passwords. Who even uses them? So the easier you make the password, the more common your password is, the easier it is to crack. The shorter your password is, the easier it is to crack. If you use something like this, do you think this is hard to crack? First of all, this is just 5 letters. Okay. Also, you think that adding special characters like capital $7 makes it harder to crack? Then you're wrong. That doesn't make any difference to the computer because the computer perceives all characters as the same. So if I'm going to run a brute force attack, trying every combination, then it doesn't matter if you're using special characters or anything. Okay. Well, the Unicode does have a large number of characters, and if Unicode passwords are supported, then even 5 characters can be devilish. But it depends. So something like Param is my best friend and he likes tea. This is very easy to remember. Param is my best friend and he likes tea. This is easy to remember, but for you. However, look at the length. Okay, 33 characters. This is not something a computer can crack easily. Also, this is not common at all and hard for any system to automatically detect. Okay, so that makes it harder to crack using any tool like hashcat or otherwise. Hence, use passwords that you can remember and others can't crack, instead of using passwords that you can't remember and others can crack easily. Okay, that is from a security point of view. Let's go ahead. We just discussed hash cracking. Okay, so I spoke a lot and now I am a little tired. We shall take a 2 minutes break, and I'll be back exactly 2 minutes after this break. Okay, so go have some water and I'll see you after this. Meanwhile, you can ask any questions in the chat if you have any, and we'll continue the workshop after this. Okay, this is not the end. Don't go away. I just asked you to go to the bathroom or have water if you need to. I'm still here. Meanwhile, let me have some water. Okay, so 2 minutes have passed already. Let's get back to the workshop. Like I said, it is not going to end so soon. Okay. The next topic in hand is steganography. And some people have trouble differentiating steganography from cryptography. And I'm going to make that clear here. Okay. So let's go ahead. Okay. In the chat, we have Mukul again. Mukul isn't going away easily. Don't worry. So, concealing critical, secret, or confidential information within ordinary information in an undetectable manner. Why exactly are we concealing confidential information within ordinary information? Because we want people to see it as ordinary, whereas it is acting as a transportation medium for our critical information. Okay, only the one intended should know how to extract the information, not necessarily decrypt, but extract the information. Looking ordinary doesn't gather attention, so since it looks like an ordinary file or an ordinary email or an ordinary web page, no one is going to suspect it, and hence the information that we are concealing remains confidential. And while talking of steganography, the cyber in cybersecurity becomes less relevant because this deals with general security as well. It doesn't necessarily have to be related to the cyber world. And this relates much more to forensics than plain cybersecurity. In terms of cyber world, we can have files within files, embedded within files, or files hidden within files, information within modified or extended information. So either we can keep the original information intact or modify it in order to have our confidential information hidden within it. Now, how do we make sure that we are successfully able to conceal our information within some other ordinary information and keep it undetectable? By making it as complex as possible, by mixing different levels of steganography and often repeating. That will make sure that only the one intended is able to extract the information and it doesn't fall into the wrong hands. So let's start with the first example, which is mysterious files. Now here we'll discuss the concept of having files embedded into files. Okay, this could be something as simple as storing any kind of information within the metadata of files or within the comment section of files, which doesn't impact the original file. It still looks and behaves the same, but there's some extra information hidden within the file, and it will generally go undetected through most systems. So no one will be able to tell unless they pay really close attention to it. So looks like we already have time for the hands-on. What's special about the hands-on for this particular exercise is that I'm going to demonstrate the same process in 3 different ways. And you are going to understand what I mean by 3 different ways here. So let's go into steganography. Okay, let me use the explorer here. Steganography, mysterious files. And we have a file here. Okay, we don't need this right now. We have a file info.png here. Okay, it is a PNG file. Let me open it. Looks like an image. What even is this image? Something beautiful. But it is a 448 cross 300 pixels image. And surprisingly 309 kilobytes. So any ordinary image like this would hardly exceed 80 kilobytes, but this is 309 to 310 kilobytes. So that is quite a lot for an image of this size. So something is wrong. We might probably be able to find some hidden information within this image file, and let's try to see how we do that. Okay, multiple ways. Let's see how we can do that. So let me first navigate to the folder. Okay, so we have this info. Okay, we also have this flag.py. What is this? Let me try running it. It asks me for a flag. What exactly is a flag? Wrong. Okay, let me try something else. Still wrong. So it expects me to enter a flag. Maybe the flag is hidden within this image. Let's try to find out. Okay, is the flag info? Let me try info. No, that is also not the right flag. That means there's something within this image that I am supposed to enter here. Okay, why am I doing this? Why am I using this flag thing as an example? Because commonly in CTF contests, capture the flag. Cybersecurity enthusiasts engage into rivalry against each other for searching for flags within security related items. So this is an example of one of those things. And the first tool that I'm going to use here is binwalk. So binwalk is a very useful tool for file magic, and I'll show you how. Binwalk info.png. So it will walk through the file and show me what kind of contents it possesses. So the PNG image, very obvious, but it also shows a zip archive, a really surprising zip archive within the image. So without wasting any further time, let's extract it. And we have a new directory here. Inside this new directory, we have a zip file that contains a house.txt, and the same house.txt file is here as well, because maybe it was able to comprehend it without even extracting the zip file. So let's navigate into the folder, and we have a house.txt file. Let's look into the house.txt file. Okay. Very dirty data. I can't make sense out of anything here, anything at all. But if I look closely, this looks like base 64. So this kind of looks like base 64. I feel inclined to try to decode it. So let me try to decode it. Base 64. This is a built-in utility. I could have used the one that I have written, but either way, -d house.txt. Okay, that was a lot, and even the command line failed to process it. So I'll be looking at just the beginning of it. So just the beginning. Okay, I see PNG here. So looks like this could be yet another PNG image, and I wonder what that would be. So I wonder what that would be like. Let's try storing it in a PNG file, house.png. Done. Okay, we have another house. Okay, interesting. So this is an actual image that was hidden inside this text file. Not really hidden, encoded in the form of base 64. I wasn't able to tell in the first sight. And looking at it, looks like a beautiful house in the middle of nowhere. But we were searching for a flag, weren't we? So there must be something like a flag within this image. Let's try to find it. For that, we will use a utility called strings. So strings is a very popular command line utility that is used to find identifiable strings within binary data or any kinds of files. So let's try house.png because that is decoded. So house.png, and let's run it. Okay. We see something that says flag. So this could be the flag, and everything else seems absurd, but this could be the flag. So let's take the flag and let's run flag.py, the Python file. Try to check if our flag is correct. Yay, it is correct. So we successfully got the flag out of an image, which itself came out of a text file, which itself came out of a zip file, which itself came out of yet another image. So this was several layers of steganography that we showed, that we went through here. And let's go further. Okay, this isn't the only way of doing this. I just demonstrated the use of binwalk. We can also use a tool called foremost and info.png. It extracts the identified data into a folder named output, and there we have a zip folder. Let's go inside that, and okay, it gives us all kinds of data. The PNG itself that is extracted here, 77 kilobytes. I told you it is going to be shorter. And inside the zip we have a zip folder, a zip file, and inside that we have the same house.txt. So now we can very simply extract it, go into folder, decode it, and then or I don't really need to store it somewhere else. I can directly run strings on top of it, and there I have the flag again. So we just I just showed you using two command line tools. Now since if we can do it using a command line tool, there must be a graphical way as well. So now I'll demonstrate the use of a very popular tool and something I love personally as well, created entirely in JavaScript and front-end web, named Cybersecurity. You can in fact very easily run this through your browser as well, which makes it easy to use. So this is Cybersecurity. Let's go there. And Cybersecurity works on the use of recipes. So what we call a recipe is just a processing algorithm that we drop in here, and we give some input and it processes it through the recipe and gives us an output. So let's try this. The info.png, I drop that in the input. And what recipe do we need? We need to search for embedded files. So embedded files. Okay, so it found different possible file types at different offsets, and it even found some mp3 files. Interesting. That wasn't done by binwalk. It could be false positive. Let's see. And some other files. We are looking for the zip file, aren't we? Okay, so I don't know. Yes, it does look at a zip file at this offset. Let's see if it is correct. Okay, let's get rid of this. Let's just extract the files. Extract files. Okay, ignore failed extractions. So it is ignoring all those false positives. Some mp3s, we have 3 bytes. That's too short for a regular mp3 file. This zip file looks promising, so let's save that. Let's save the zip file, open it. We have the house.txt file here. Let's copy this file here and let's drop this. Okay, now now we are going to work with this house.txt file. So let's clear the input and the recipe, and let's get this file into the input. And as we know, this is base 64, so we can do base 64 decoding from base 64. So we'll get that here, and looks like a PNG, but again we were looking for a flag, so we'll get the strings recipe and add that here. And this behaves exactly like the traditional Linux strings utility, and we need to scroll down, and there we have our flag. So this was doing the same thing using yet another utility known as CyberChef, which is a much graphical version of file magic utilities. So here we just discussed mysterious files. Let's go to the next one. Textual cover up. So we can in fact cover up information by transforming into another format, from textual to non-textual, from non-textual to textual, from non-textual to non-textual, and from textual to textual as well. Okay, so it can be transformed from any format to any format. There are so many ways to hide information that we can do pretty much anything. For example, I have an image, I make some slight changes in that image in order to store my information within that image, and those changes are quite undetectable by the general folks, so they will never realize that there's anything hidden, and the intended person will have the image and be able to tell, okay, this is hidden, or maybe be able to extract that. So we are just in the context of textual to textual cover up, we are just twisting the meaning of the text. Okay, and complexity for the win. The more complex it gets, the harder it becomes for anyone to be able to decode it. Okay, so let's okay, time for a hands-on, I guess. Yes, let's go do the hands-on for this as well. Okay, so steganography, textual cover up. Okay, in this directory I have a file that's named story.txt. What does this file have? Okay, this is the one. Looks like a play. Okay, it does look like a play, maybe a story. Doesn't make much sense, but still looks like a story, right? Although if it is here, then it probably isn't. There's something hidden in this, and this story is created using an application that I used to fascinate over when I was a kid. That is exactly why I am demonstrating this to you. Its name is the Playmaker, which was a very interesting steganography tool during my childhood. So that is exactly what it looks like. It has been generated using. So let me open the tool. Where do we have it? Playmaker, and there is the playmaker. So this is the playmaker. You can give it any text and it will convert it into a play that can't at first sight make you realize that this is some message. So let me try to decode it. Okay. This is again the line feed thing. CRLF LF. So let me make it CRLF. Copy it and try to decode it. Weapons at site B. That's what I get. Weapons at site B. Such a dangerous message stored within an otherwise innocent looking text. So we were successfully able to store sensitive information within text like that. Okay, why did I choose to use that particular statement as an example? Because I want to demonstrate how it can be exploited in the real world and why forensics and detective agencies have to work hard for figuring these out, and why it is hard to always be able to tell that someone is hiding information within ordinary information, how hard it can get, how complex it can get. This is just a very simple example. One can make it even harder for anyone to understand, and this is just a cyber experience. In the real world it gets even tough. Okay, now let's get into a very interesting topic, that is reverse engineering. Now, what is reverse engineering? Reverse engineering, first of all, is not limited to, is not much to do with engineering specifically, but it is like the opposite of creating. Okay, getting the raw material back from something that has already been created. This is not limited to the cyber world. Okay, deconstruction of a proprietary product or a built product, something that has been compiled, that has been created, ready for distribution, to extract design information. And reverse engineering is useful only to those who are attempting to either understand the functionality, maybe get the code out of the application, or inject unwanted code, inject their virus into something and then distributing a malware version of the application, or someone just trying to hack into proprietary software and use it for free. And we have a large number of people doing that with software by big companies like Adobe. And if you think that they don't know about this, they do. Okay, it is also part of a strategy, but let's not get into that. How do we avoid reverse engineering of our applications? By obfuscation, of course, and complexity, making it so complex that it is hard for anyone to decrypt it. That is something we do with Webpack as well. You know, if you have heard of Webpack, it is used to generate a bundle of all the JavaScript in our front-end web applications. And that's just a very small typical definition of it. It is used for much more, and a useful utility indeed. And it becomes hard for anyone to understand the code, and it is minified, delivered quicker, in a much faster way. So those are the benefits. Let's start with the first example, finding strings. So we just did this a while back, finding strings. We just found hidden string within an image file, within a text file, within another zip file, within another image file. So we are going to use the same utility to extract textual information within distributable release binaries. So that is a release binary, a compiled binary of a program that we are going to try to find strings out of. And this does not involve injecting code. This only involves reading code, getting information out of code. Okay, and maybe we are not even extracting code, maybe we are just finding out the strings. Let's see, let's find the strings literally. Okay, only hard coded information can be extracted using the hands-on that we are performing, which is why it is recommended not to hard code license information unless it is an operating system itself. So let's do this. Okay, finding strings. Okay, looks like we need to compile something. We have this binary register. So let's try running it, seeing what it says. Okay. I forgot to delete the registration. Sorry about that. How would I demonstrate it to you? Okay, register. So let me run it. It asks me for a license key. So looks like a proprietary application, and I need the license key for that in order to be able to access it. But I don't have it. So let me try putting in something random. Doesn't work. Let me try leaving it empty. Doesn't work. Doesn't work. So now is the time that I would try to look inside the compiled binary that I have received and try to see if I am able to find the required credentials. And in this example, I suppose it will be quite easy. So I see lots of strings here, dot comment, dot symtab, main, looks like a function name, verify. This looks like, this kind of looks like a security key. This looks like a license key. So let me just copy it just in case. Maybe this could be it. Who knows? And looks like these are all possible messages that are shown by the application while running it. Interesting. So let me try to run it again. Okay. Let me try running it and entering this key. And I am successfully registered. Such a lame way of registration, but since it was hard coded into the release binary, I was easily able to find it just by looking at the strings hidden within the binary itself. There are many other ways to do this. Okay, maybe I can create an application that stores the string as a hash. Then it would be harder for anyone finding the hash to be able to tell what the key is. So that is a good way to do it. And there are several other ways to do it as well. The best way, I suppose, is to do server-side authentication and server-side license validation, which is the example that we're going to discuss next. So we are done with this. Let's go ahead. Code inspection. So code inspection means actually inspecting the code in hand, actually being able to look into the code that we have and identifying what it does, identifying the functionality, and maybe trying to manipulate it. We don't necessarily need to manipulate everything that we are able to identify, but identification itself is a big deal. If you are distributing a proprietary application and everyone is able to identify what the code does, maybe they will try to exploit its vulnerability. And maybe if your product requires authentication only to licensed users, they might be able to bypass it very easily. Okay, let's do the hands-on for that. So let me start the application. Okay, it has started. And meanwhile, I was given the application as an HTML file, and the server is running somewhere else, and the server is supposed to do the authentication. Let me run the application. Tarazu Premium E-weighing solutions. How interesting. Nice. But I don't have a license key to it. So how do I use it? Now, since this is being distributed as a standalone HTML file with some JavaScript in it, maybe I can very easily look at the source code and tell what it is doing. Now, of course, people could have made it harder by maybe obfuscating the code or minifying it. Thankfully, these people failed to do that, which makes it easier for me to crack it. So let's look at the source code. It looks like the style is embedded as well. Going further down tells us that The script is embedded as well. Okay, very well. And what is it doing? So when I enter the license key, so let me try entering something A, B, C, D, and I press enter. Verifying invalid license key. Please try again later. Let me try leaving it empty and then pressing enter. Still invalid license key. So looks like it is communicating with the server to validate the license key, but it is failing because I am not giving it the correct license key, and I don't even have the license key. So I'm going to try something else. Let's look at the JavaScript more properly. Now this is similar to the problem that we had in the previous example of service isolation, that the authentication is relying too much on the front end. How exactly? Well, I am able to see the source code first of all. So that is the biggest thing here. If the source code was unclear to me, maybe obfuscated, maybe compiled, then it would have been harder for me to do what I'm going to do. But right now I can tell, okay, it is doing a fetch to the backend, and if it is okay, if the license key is okay, then it is calling these two functions, and it is calling some show tarazu function, else it will say invalid license key, which it is showing me. So let me look at the show tarazu function, where it is. Okay, this is the function, and this function seems to be doing a couple of things, but this function is of interest to me. So let me try running this function myself. So tarazu, let me try running this application, this function, and suddenly I have access to the premium e-wing solution without having the license key. So I didn't have any license key at all, and I'm still able to access the application because I went through its source code, which thankfully I was able to, and I exploited it. So now I have access to this really amazing software without having to enter the license key. I can make this change permanent by editing this file itself. So let me try editing the file, the game.html file, and let me call the show tarazu function regardless. So now next time, as soon as I open the application, I don't okay, it didn't work. Maybe did I miss something, or okay, I did place it wrongly. So let me try loading it again, and this time it won't even ask me for the license key and automatically load the application for me because I added it, I modified the source code, and now it is automatically considering me as someone with a valid license because it is calling the function that is supposed to be called after validating the license. So now I have access to this really amazing application without having to know the license key. So that was the hands-on for code inspection. Let's go ahead, and I think at this point we are reaching the end of the workshop. So the last topic is about to come, and it is really interesting. Penetration. Now, most of the people who get into cybersecurity start from here only. And you must have heard about terms like pen testing, penetration testing, that is. And this usually involves breaking into the system, like the name suggests. Breaking into the system, penetrating, damaging the system, or enforcing our control over the system. Okay? It can, or it might cause temporary or permanent data loss or financial loss to the organization whose system we are trying to penetrate through. And how exactly do we make sure that our application isn't vulnerable to penetration? By maintaining a regular backup of the data, by maintaining security of our application, and by making it adaptable. So what do I mean by adaptable? Scalable, elastic, and having multiple instances to make sure that people don't have a downtime due to some mischievous people, and our application remains secure and safe. Keeping it updated is also very important, which we'll come at after this. So before actually starting with the examples of penetration, I would like to bring up the concept of CVEs, common vulnerabilities and exposures. This is a well organized, world known system for organizing publicly known vulnerabilities in all kinds of systems. And every CVE, every record is given a unique identification number and a proof of concept of that particular vulnerability. Now, generally, as soon as these vulnerabilities and exposures are identified, they are resolved as well. But in order to keep our systems well maintained and protect them from such vulnerabilities, we also need to keep it updated. So as soon as it is resolved, we have the latest version of the software which has the vulnerabilities resolved. So keeping the system updated is recommended. Let's go to the first example of penetration, which is denial of service. What is denial? Rejection. Saying no, you are not going to get this. Denial. So denial of service. If I am operating a service and I deny my service to the users, that's fine. That's my choice. But if a hacker is able to deny my service to my clients, then that is not okay. And how exactly can they do this? There are many ways to do this. They can just put a heavy load on my server that makes it hard for my server to respond to genuine clients. So denial of service, the attack, is making the resource unavailable to users by causing temporary or permanent disruption of the service. And doing this is not as big of a deal as it is to go undetected, because going undetected is the bigger challenge. Denial, because hacking into other systems and denying their service is illegal. You might land up in the jail for that. And ensuring that the system is not vulnerable to this is the job of an ethical penetration tester. So the organization hires an ethical hacker who tests all these attacks on the system and makes sure that before deployment the system doesn't remain vulnerable to any of these attacks. And that is what we are learning this for as well. We are learning this in order to become ethical hackers who test systems to ensure safety, not to become an unethical hacker who does something wrong. And how important is the concept? Well, Google, every moment thousands of people worldwide are opening google.com and still it loads with such efficiency. How is it able to do that? By making sure that it has a large number of instances running, that it has a huge availability area, and it caches lots of things here and there to make sure the closest server gives the information to the user, and a large number of things that it does internally that even I don't know about. And we are supposed to do that for our applications as well, especially protect it against for protecting it against the denial of service. So time for a hands-on, and I'll show you an example of an application that is vulnerable to denial of service. So let's go into penetration, denial of service. Let me pull up the application, and looks like it is running. Let's go to localhost :8080. Okay, looks like a very simple application that does nothing but show me the current date and time. Okay, Greenwich Mean Time. So it is only showing me the current date and time, and whenever I refresh it, it refreshes the date and time as well. Very nice. Looking into the source code, this is not client side dynamic. This is coming from the server side itself. If I refresh it, the source code changes. So nice application. However, the problem is it is vulnerable. How exactly is it vulnerable? If I make too many requests in a very short time, the server is not able to bear the load and it crashes. So let's try. I have something in the same directory named pyfludder.py. So this pyfludder.py is a Python script that makes a large number of requests suddenly onto the server and crashes it. So let's try this. pyfludder.py, the website, localhost, the port 8080, and how many get requests are supposed to be done. So when I open the web page, what I do is a get request. There are multiple types of requests. We have post requests, patch requests, delete requests, but we're not getting into that. Let's do at least 5,000 get requests at once on this server, and let's test how much it can handle. Let's try 10. Okay, let's try 10. Okay, it did, and nothing happened. Let me open the website. It is still working. Nice. It is able to handle 10 requests. Let's try 100. Okay, looks like it crashed. So the website is not working anymore, and now I can't access the application. Let's go into the details and see what happened. Let's look at the logs, and looks like something happened. The application crashed. Very well. So we loaded it with too many requests in a very short time, and our server was weak enough to get crashed just by overloading too many users. So this doesn't really happen because modern servers are very powerful, but this example was easy enough to demonstrate how simple it is to crash servers that are vulnerable to denial of service. And this is just one of the countless ways to do denial of service. We can break into the system and make it do something that we want it to do. That will also be denial of service. This was just a particular example. So let's go ahead to our last example, which is remote code execution. Remote code execution sounds like injection, but how is it different from injection? In the case of remote code execution, we are establishing administrator level control on the server side. So we are gaining control over the system like we always have, except in this case, we are establishing system privileged level control. So we are going to execute commands on the server side that are supposed to be run only by a system administrator. And all these attacks that I mentioned are generally initiated with a reconnaissance. So in order to identify the vulnerabilities and exploit them, we first need to know what the system is running on. And that is what we usually start with. We usually do a reconnaissance, which is nothing but an observation of the system in order to get some information about it. Okay, this is google.com. What else do we have here? Do we have accounts.google.com? Do we have mail.google.com? If we do, are all these SSL protected? What server are they running? What operating system are they running? Are they running on Linux or Windows? What server are they running? Is it Nginx? Is it Apache? Is it their own proprietary server, or is it something that we can't see? So we first need to do a good observation in order to know what vulnerabilities we can exploit. And if we get the servers and the version numbers, then we are in the right condition to be able to exploit. So again, ensuring safety practices, safety measures is the job of an ethical penetration tester, a security person who's a part of the team and who makes sure that security information is not being leaked, and if it is, then it is not easily being exploited. So let's go ahead with the hands-on. So for the hands-on of this particular vulnerability, I will be demonstrating a particular CVE to you, which is CVE 2019-11043, which was a vulnerability in PHP that was quickly fixed, but it is still there in the commit history. So we have a proof of concept that we can use to demonstrate that. So let me start up the server and I will show you. It is a very simple PHP application running behind an Nginx server, but currently we are exploiting a PHP vulnerability and not an Nginx vulnerability. So let's go ahead. Okay, there we have it. PHP and Nginx are successfully configured to work together. You may now edit the files to host your own app. So this looks like the starting page of a newly created server. which shows us a message, okay, your server is working fine, it is configured, now you can put your application here. However, accidentally I forgot to close the server, or maybe it was left open, and since it is a vulnerable server, someone might try to exploit it. And how exactly? Let's see. So this particular version of PHP that it is running on, we use a large number of tools to figure that out as well, but I'm not going to show that in this workshop because it will be very long. Let's keep that for later. If you are interested, you can let me know. So we will be using this particular proof of concept tool, which is PHUIP It is the exploit written coded in Go. So you can run this command if you have Go installed in your PC to pull it, and then you can execute it. So it requires us to provide a path to a valid PHP file. So assuming this website comes from index.php, I am going to give that. Let's test it, index.php. Okay, so it actually is running index.php, and let's run the exploit. Okay, I gave HTTPS. It is not HTTPS at all. Okay, so looks like it was successfully able to very well. It was successfully able to run the exploit, and excellent. Now, after running this exploit, what we can do after having the server damaged, we can very simply add a query parameter A and pass any command that we want to run. So, for example, echo 123. This is supposed to print 123. Let's look at the source code for a better visibility. And let me refresh the page. So, it doesn't work all the time, but it does. So it says 123. As you can see, I can see 123 here, which isn't supposed to be a part of the web page, but now it is, because I am executing a command on the server side. I don't know what other kinds of privileges I have. Let me try to execute the id command. And we have the output of the id command as well. We can see all these different IDs. Interesting. What else can we run? Maybe we can run Nginx version. Maybe. Let's see. Okay, didn't work. Okay, this isn't working. That's fine. Let's try running other commands. For example, I want to see the contents of the root directory. Encode URI component. I'm going to run ls/, which is nothing but listing the contents of the root directory. So I'll copy this, add it here, and I'll execute it. Didn't work. Refresh. Okay, it worked, and now I can see all the contents of the root directory. So everything that I'm doing right now, I'm not supposed to be able to do all this, but just because the system is vulnerable, I'm able to execute commands on the server side by using a very simple exploit, which worked on this PHP application running on top of Nginx. So that was the vulnerability, and this was an example of remote code execution. So with this, we have reached our last example. That was the end of this workshop. Okay, don't go away so quickly. Let me tell you a couple of other things as well before you go. So thank you for attending. First of all, this was our first workshop. At PyData, we generally conduct workshops through Google Meet because not all workshops are this large in terms of scale. We discuss a large number of things, and we have so many more things planned in future. So and also after the workshop, we are going to have a meeting in our Discord server where we'll be discussing doubts. And if anyone of you forgot to fill the attendance, go ahead and do it, because that is required for the certificate. And join our Discord server if you want to have more future workshops like this. Do subscribe to my channel. I really need a lot of support. I work very hard. Okay, not bragging. And that's it for the workshop. Thank you for attending, and I'll see you in the next one. Goodbye.